guys, Physics in the Flesh is back with another one-dimensional momentum problem. This time we're going to start doing elastic collisions problems. A ball of mass 0.450 kilograms moving east in the positive x direction with a speed of 3.05 meter per second collides head-on with a 0.222 kilogram ball at rest. If the collision is perfectly elastic, what will be the speed and direction of each ball after the collision? So before we get started in the actual problem, I want to just show you some theory here. Okay, what is the idea behind a perfectly elastic collision? And that's what we're dealing with here. Okay, so the criteria are this. If you have a perfectly elastic collision, that means that there's no loss of kinetic energy in the collision. That is very important because that's not true for the inelastic ones. Momentum is conserved. That is generally true. The thing you also should know about the elastic collisions is that they're rare. Okay, so for there to be no loss of kinetic energy, I mean, usually when things collide, especially let's say billiard balls, if they collide, you hear something. You hear one ball smack the other, and that means some kinetic energy got lost to sound. Some gets lost to heat. There's friction, right? So it's very rare to have a perfectly elastic collision, but collisions between ideal gases get very close to this. So it is possible to have it, and we're going to assume those ideal conditions for this problem. So again, no loss of kinetic energy, conserve momentum, that's perfectly elastic. Okay, so let's go ahead and start drawing a picture for our problem. This is a generalized picture of a mass A hitting mass B and them going off. Now, here's the thing. In this problem, it tells us the ball collides head on. Now, if this ball MA collides slightly off to MB, not exactly dead center, yeah, they're going to go off on angles. But if you hit a dead center right on the middle, they're going to both go straight because none of them have a reason to go off at an angle. So, with these kinds of problems, I always want to start with a before and after scenario. So here's going to be my before and here's going to be my after. Okay, so before I've got ball A heading over towards ball B, which is at rest. Okay, so after the collision, they're both moving forward. Okay, and the reason for that is because it's hitting it head on. If it hits it with even the slightest angle, they're both going to go off on an angle. Okay, so let's write down our knowns. Mass of A is 0.450 kilograms. The initial speed of A is 3.05 meters per second. For B, the mass of B is 0.222 kilograms. The initial speed of B is 0 because it's at rest. Okay, and what we're asked to find is the speed and direction of each ball after the collision. So we're looking for V2A. Well, specifically, we need the velocity, right? Because it wants the direction too. But like I said, because they're both going off on a straight line, you just have to find the speed, and then the direction, you can just say, well, east, as they say in the question, or positive x direction. So here's what we're looking for, V2A, V2B. So hopefully you see this as a conservation of momentum problem, and the fact that it's perfectly elastic, well, you get to also use the conservation of kinetic energy. So that's nice. So you know what, we're going to start off with that. Conservation of kinetic energy. And remember, that's only for elastic. So what that means is the kinetic energy before the collision has to equal the kinetic energy after the collision. So before, we can call that part 1, after part 2. So we can say that EK1 equals EK2. Now, you guys know me. I'm going to do this again where I write all of the stuff. So I'm going to write the kinetic energy for A and B in the beginning, A and B after, even if they are 0. I can always cancel them out after. So initial kinetic energy of A, 1/2 ma V1a squared, plus initial kinetic energy of B, V1b squared, equals 1/2 ma V2a squared, plus 1/2 mb V2b squared. Okay, first thing I notice, there is a half appearing in every term. Imagine factoring it out on the left and the right, canceling it out. So those halves all disappear. Okay, the next thing I notice is, well, I already defined V1b as 0. So if that's 0, 0 squared times anything is 0. So that whole expression disappears. So we've simplified our expression quite a bit. Now we have ma V1a squared equals ma V2a squared plus mb V2b squared. Okay, so here are our two unknowns, v2a, v2b, and that's what we need to find. We've got two unknowns and we've got one expression. Now, as you know in math and physics, whenever you have two unknowns and one expression, you need another expression. Okay, so we're going to do now another expression. We're going to use conservation of momentum to make the other formula. Okay, so conservation of momentum, P1 equals P2. So again, P is mv, so ma v1a plus mb v1b equals ma v2a plus mb v2b. And just like before, I know that v1b is 0, so this whole thing goes away. So I'm left with ma v1a equals ma v2a plus mb v2b. Now these two expressions look very similar, except in this one, the speeds are being squared. Okay, so what I'm going to do here is I'm going to solve for v2b. Right? You just solve for one of them and you're going to plug it into the other expression. So solving for v2b, notice you have ma and ma. If you do ma v1a minus ma v2a, so you bring this to the left, you can just factor out the ma already. So you can do ma v1a minus v2a, right? That takes care of that. And then you're going to be left with the mb v2b. Divide both sides by mb, and you're going to be left with v2b. Now, in this expression, I have v2b squared. I'm just going to go ahead and do that here and then plug it in, okay? Just to make things a little bit easier. So v2b squared is equal to ma squared. v1a minus v2a. Make sure you don't square in the individual parts. This bracket has to be squared, the expression, because this whole thing squared is not the same as these two squared and then subtracting each other. Okay, so there's my expression for v2b squared. I'm going to take that, that's going to get plugged in over here, and I'm going to get a new expression. So ma v1a squared equals ma v2a squared plus mb bracket ma squared bracket v1a minus v2a squared over mb squared. Okay, so I can start canceling some things out. I've got ma in every single term. This is one term because this is getting multiplied to that. This is a term in itself. Okay, so I can cancel out ma here, ma here. I can cancel out one of them from there. And I can cancel out the mb's, well, one of them. One of these mb's with this mb. So that goes away as well. So then now you're left with an even more simplified expression. v1a squared is equal to v2a squared plus ma over mb. Now you know what I'm going to do here. I'm just going to go ahead and expand this out, the v1a minus v2a. Okay, just expand that out. When you do, you're going to get v1a squared minus 2v1a v2a plus v2a squared. Now, the reason I did that is because notice I have an expression in terms of v1a, v2a, right? The v1a I was given in the problem, right? It's 3.05 meter per second. So I can solve for v2a, and ma and mb I already have. So at this point I want to expand this out. So, and why not just bring the v1a squared to the right as well? So let the left side be 0. What I'm trying to do here is make a quadratic expression involving v2a instead of x. Okay, so 0 is equal to, you got your v2a squared, and then you bring the v1a squared to the left, so it becomes minus v1a squared plus v1a squared ma over mb. That's your first term here, right? Because you're expanding it. So this gets expanded to all three parts here. Okay, so minus 2 ma v1a v2a over mb. That's my next term. And finally, plus ma over mb v2a squared. Okay, so it looks a bit messy, I know, but try to see the expression how I want to do this with the quadratic formula. Okay, so I've got, this is my unknown. I've got a v2a squared here. I've got a v2a squared there. I've got a v2a here. And then, of course, you have your standard term. So I'm trying to get it into this form. ax squared plus bx plus c equals 0. Where x, here x is going to be v2a. Okay, that's what I'm trying to do. So let's get the V2A squareds together first. The number in front of this is technically a 1, and you've got an MA plus I've got an MA over MB there. So then combining those two, I'm going to have 1 plus MA over MB V2A squared. So there's my V2A squared term. Now for the V2A by itself, this is what's in front of it right here. Okay, so the minus 2MA V1A over MB. So that's what's going to go next. So minus bracket 2MA V1A over MB V2A. And finally, so we took care of this term, and this term. So whatever's left over, these two parts, that's like the constant term. That's the C. Okay, so I want to put this in brackets. So I'm going to put minus V1A squared because that's a minus V1A squared. But if I put this in the bracket with it, see the minus is out in front? That means I have to compensate for that and put another minus. So that when you expand this minus, this becomes negative, which it is, and the next term becomes positive, which it is. All right, so minus V1A squared MA over MB. Yeah, all right, guys, so that's it. Now let's plug in our values. You see the expression? You've got your A term, so this is your A, this is your B, this is your C. Of course, your C should be negative, right? And your B is negative because according to the expression, they should be positives in between. Okay, so I'm just going to plug in my numbers now and see what I'm getting. So then I can plug this into the quadratic formula and solve. So 0 equals bracket 1 plus 0.450 kilograms over 0.222 kilograms V2A squared minus 2 times mass A 0.450 kilograms times 3.05 meters per second divided by 0.222 kilograms, and that's V2A. And then finally minus 3.05 meter per second squared minus 3.05 meter per second squared times 0.450 kilograms over 0.222 kilograms. Okay, so that's a lot. I know it looks like a lot. Do it one by one. Solve this, then this, then this. Get the numbers. Okay, so when you do that in your calculator very carefully, you're going to get 3.03 for the first term, so V2A squared. You're going to get minus 12.365 V2A for the next term, and finally 9.554 for the last term. Okay, so of course you can go ahead, plug this in the quadratic formula. There is a way to do it using just a standard calculator. Okay, so in fact, I use this calculator right here. I use the Casio FX 115 ES Plus. It's a good calculator, and most of them can actually solve quadratic formulas for you. In fact, I can show you how to do it. So go on, press mode. Hopefully you guys can see that. Let me try turning the light off. It might be easier. Okay, let's see if I put that here. There we go. Okay, you want to press 5 for equation, or whatever one says equation, and then you've got a list of different types of equations you can choose from. I'm going to choose number 3, ax squared plus bx plus c equals 0. So you press 3, and now it's asking you for the a term. Okay, my a term is 3.03, so enter your number 3.03, press equals. The next number is negative 12.365, remember, because that's a plus here technically. Minus 12.365, and C is 9.554. That's positive, so you can leave that as is. Press enter again, and you get your two values. Okay, so what I'm getting here, it's saying that the first V2A is about 3.05 meters per second, and you press equal again to get the next one, and the other one is 1.04 meters per second. If you want to go back to regular mode, just press mode again, and then 1, computer. Okay, or computation. So there are our two V2As, our two roots. Now at this point, you have to ask yourself which one makes more sense. Okay, so in the question, the ball initially has a speed of 3.05. So if this initially is moving at 3.05 and it collides with this, it can't keep moving at 3.05 because some of its kinetic energy went to B. So it has to be going slower. So in other words, this answer does not make sense. So this answer makes sense, 1.04 meter per second, right? Because again, some of the kinetic energy of ball A goes to ball B, so it cannot have the same speed that it struck ball B with. Okay, so there's our V2A. Now at this point, we have to find the other part as well, V2B. And you know what? I'm just going to use this formula right here, right? The one we found earlier, V2B star, right? I starred that formula back over here. So you know what, guys? Just bear with me. I'm just going to try to squeeze it on this page because I am green and I'm going to try to save this. So here we go. V2B equals MA, right? So MA is 0.450 kilograms times V1A. Oh, I can turn the light back on. Sorry. Times V1A. V1A is given in the question. It's 3.05 meters per second minus V2A, which I just found, 1.04 meters per second. And divide that by the mass of B, 0.222 kilograms. And when you plug that in your calculator, you are going to get 4.09 meters per second. Okay, so there's your V2B. I have my V2A. And just to make everything final is your final answer, you have to give the direction with it. So because the question told us that going to the east direction, positive x is east, we're going to express it like that. Therefore, V2A, put the vector symbol on top, equals 1.04 meters per second east. And V2B equals 4.09 meters per second east. Alright guys, so that's it for this video. There's your final answer. I know that was very long and I really appreciate you guys for sticking it through. It's going to be worth it once you guys end up doing your tests or your quizzes or whatever assessment you're going to have. Anyways guys, that's it for this video. Be sure to smash that like button and subscribe to Physics in the Flesh. I can't wait to see you guys tomorrow for video 124, Elastic Collisions 2. What? Wait, who's back to school? Pumpkin pie recipe. Okay, I'll save that for Halloween. Guys, so that's it for this video. I hope you enjoyed it. If you did, be sure to smash that like button and subscribe to Physics in the Flesh so you never miss a video from me, which by the way, I post every weekday at 12 noon. So be sure to be on my channel at that time. Guys, as always, if you missed my videos from the past, be sure to click over there on the right. You'll see some of my latest videos there. And other than that, guys, I hope you enjoy the rest of your day. Peace.